In this example, we are going to be determining surface area and volume. Keep in mind that a surface area is the entire outside surface of some geometric solid. So for this problem, it says, wooden children's blocks come in a variety of geometric solids. One of the blocks looks like a ramp. It is a right triangle prism. Suppose the dimensions of the block's triangular face are 4 centimeter base, 3 centimeter height, and a 5 centimeter hypotenuse, that's its diagonal. Its width is 1.2 centimeters. Determine the surface area and the volume of the wooden block. Now, a right triangle prism is known as a polyhedron. A polyhedron is a polygon that is bounded by other polygons. So I'm going to draw that. It looks like a ramp, so I'm just going to draw a right triangle here. So here's our right angle. I'm going to put in the dimensions here. It says this is 3 centimeters here, 4 centimeters here, and then the hypotenuse, which is right here, that's 5 centimeters. That's its diagonal. So this is known as the face of our polyhedron. It then extends, since it's a prism, it then extends 1.2 centimeters that way. I'm just going to connect it here. So here is our triangular prism. So this prism is made up of a variety of faces. We have this face right here on the front, which is our right triangle. We also have another one that's on the other side. But then we have these rectangles here. We have a rectangle in the back here. We have a rectangle that makes up the bottom. And then, of course, we have a rectangle that makes up this ramp portion right here. So if we find the area for each one of those separate polygons, we go ahead and we sum it all up, and we have the surface area. So the surface area, the area for a triangle, that is the base times the height divided by 2, or 1/2 the base times the height. So we have a base of 4 and a height of 3. That's going to be 4 times 3 over 2. That comes out to be 6 square centimeters. That's this right here. Now we have 2 of them. We have one that's coming from the other side. Here is a mirror image. So the surface area for the 2 faces, that's this one in the front here, and then the one in the back, they're going to total 12 square centimeters. Then we have a rectangle in the back here. That's going to be 3 centimeters by however deep it is. Well, that's 1.2. And of course, the area of a rectangle is the length times the width. So we have 3 times 1.2. So that's 3.6 square centimeters. That's the area for the one in the back here. Then we have the bottom here. That's going to be a 4 by 1.2 rectangle. So the area for that one, 4 times 1.2. That's 4.8 square centimeters. And then the last face is the ramp right here. That's 5. That's the length of the hypotenuse here by 1.2 rectangle. And that's 6 square centimeters. So then the total surface area, we just go ahead and add up all the individual areas for the individual polygons. So we got a 12 square centimeters, 3.6 square centimeters, 4.8 square centimeters, and then 6 square centimeters. We add them all together, and then the total surface area, we'll just mark it as SA, is 26.4 square centimeters. So that is the total surface area. The volume, we find the volume similar to how we would find the volume of a rectangle. Now the volume of a rectangle, that's the length times the width times the height. Or in other words, all we have to do is find the surface area of one of the faces and then multiply that to the height. So it's the same idea here. We'll just find the surface area of one of the faces, which we already did right here, which is 6 centimeters, and then multiply that to its height. And in this case, maybe we could think of it as its depth. So the volume here is going to be 6 times 1.2. The surface area of this right triangle here times its depth. So that comes out to be 7.2. And that's cubic centimeters, so we'll label that to the power of 3 with that little 3 up there to designate that we're talking about volume.